In this video, we're going to dive deeper into properties of isosceles and equilateral triangles. If you remember from our previous video, isosceles triangles are triangles that have at least two congruent sides, and an equilateral triangle is a triangle where all three sides are congruent. All right, so in an isosceles triangle, we have two pairs of base angles, and the top angle is called the vertex angle. All right, and the angle-side relationship, which I believe I touched on in the previous video, says that if two sides of a triangle are congruent, so if we're given that AB is congruent to BC, then the angles opposite them are going to be congruent. So if we have an isosceles triangle, the sides that are congruent, the angles that are opposite of those are called the base angles, and those base angles are going to be congruent. All right, and the converse of that just basically means we're going to flip-flop that theorem. Says that if the base angles are congruent, then the sides that are opposite those base angles are also going to be congruent. So if angle A is congruent to angle C, then the sides opposite of those angles are going to be congruent. BC will be congruent to side length AB. Okay? So what can we conclude on this diagram, triangle FGH? Well, we're given that FH is congruent to GH. So we're given that two side lengths are congruent. So that means we're dealing with an isosceles triangle. Therefore, the angles opposite those sides, the base angles, have to be congruent as well. Okay, so F and G, these are the base angles. All right, let's go over some more vocab and some more theorems of what's going on inside an isosceles triangle. So if we have an isosceles triangle here, so segment AB is going to be congruent to segment BC. If there's a line inside of your triangle that bisects the vertex angle, okay, so angle B is my vertex angle, so it bisects that angle, it cuts it in half. You can see that because each of those angles there have one swoop, so those are congruent. So that line inside of my isosceles triangle bisects the top angle, the vertex angle. So what can we conclude if that's what's going on? We can say that this is a perpendicular bisector to the base. So it's perpendicular to the base, and it cuts the base in half. All right, so if we've got this isosceles triangle here with these base angles congruent, and we got a line inside the triangle that cuts the top angle in half, it's going to cut the base in half and be perpendicular to the base. All right, what about the converse of that? What about the flip-flop? If we've got a line inside of our isosceles triangle that is a perpendicular bisector to the base, so we've got an isosceles triangle here. AC is the base. The line inside that triangle is cutting AC in half, and it's perpendicular to AC. All right, then what is it doing to my vertex angle? It's cutting the vertex angle in half. Okay? Now, we can use these properties to find missing parts of a triangle. So in example 2, we're dealing with an isosceles triangle here. The line inside is cutting this angle. Let me get a different color. This angle in half. So this is my vertex angle, which means that my green angle swoops are my base angles. Therefore, the sides opposite those base angles are going to be congruent. Okay? So, I know that 35 and x plus 15, those represent these side lengths. Oops, what's happening? Why is it erasing? Those represent these side lengths. I know that those need to be congruent. Those need to be equal to each other. Those two side lengths are going to be equal. All right, so 35 minus 15, my x value is going to be 20. Okay, now what else can we fill out in this diagram Well, I know that this base is being bisected. All right, being cut in half. So if this part's 21, that means that this part has to be 21 as well. All right, now, how am I going to get to y? Why is this line inside of my isosceles triangle? All right, well, what if I draw this separately? This upper half separately. I've got that this side is 21, this side is 35, and this missing side is y. Well, what type of triangle is this? This is a right triangle. How can I solve for a missing side length using a right triangle? I can do the Pythagorean theorem. All right, this is my hypotenuse, and 21 and y are my legs. So I got y squared plus 21 squared is equal to 35 squared. All right, so if I do this, if I simplify some stuff in my calculator, I get y squared plus 441 equals 1,225. Subtract 441 from both sides. And I'll get y squared equals 784. Last step, to get rid of that exponent, I'm going to square root both sides. And I'll get y equals 28. Okay? So y is going to equal 28. We got x, we got y. We're good to go. All right? I don't know anything about the angles, so I can't tell what these angles actually are. All right? But if I was given some information with the angles, with that 90 degrees, I could be able to find missing angles. Okay? Just know for right now, we can't solve for any missing angles in this diagram. All right? So let's see what's next. Equilateral triangles. So this is just a relationship with equilateral triangles. If it's equilateral, so if all the sides are congruent, it's also going to be equiangular. All the angles will be equal. All right. On the flip side, if it's equiangular, if all the angles are equal, it'll be an equilateral triangle. Which makes sense because of this angle-side relationship. If all the side lengths are going to be congruent, then all the angles opposite those sides are also going to be congruent. All right? On the flip side, if all the angles are congruent, then all the side lengths opposite those angles are going to be congruent. So, what can we conclude on this diagram? That it's an equilateral and equiangular triangle, and that angle R is congruent to angle S, which is congruent to angle T. All the angles are going to be congruent, and their measures are all going to equal each other, and they're all going to be 60 degrees. All right, so that's a couple of the things that we can conclude on that diagram. Because all my side lengths are congruent, they're all 3. That means the angles opposite them are going to be congruent. They're all going to be 60, because 60 plus 60 plus 60 equals 180 degrees. All right, so use those properties. Use that idea of the angle-side relationship that I've talked about. And I'm going to come up here. I want you to pause the video. I want you to try out these you try nows. Great quiz test questions in here. So let me know if you have any questions. Other than that, make sure you do your practice problems.